Okay, for this homework, we already did number 1 in class, and we did number 4 in class, and I just wanted you to finish the other ones. So these are the different topics that are going to be on the test. Let's look at the section 2, factor completely. The first one is a greatest common factor. Notice there's a 14 and a 30. What goes into both? Notice there's an extra V, as in Victor, in both. So I can divide in a 2 and a V into each. So a 2 and a V is my greatest common factor, and I'm left with a 7V minus 15 at the back. How do I double check to make sure my factoring worked? I could just multiply this, 2 times 7, and V times V, 2 times negative 15, and I'm good. There's my factors. All right, the next one can be done like this. And then what times what makes 160 and subtracts to negative 6? You got it, 10 and 16. Which one gets the negative? And so it's asking me for my factors. So I'm going to give, actually, sorry, let me move this over for you. Negative 160 is 10 and 16. This one gets negative. So my factors are x plus 10, x minus 16. On this bottom one, notice there's a greatest common factor that needs to come out first. So 2, leaving me r squared minus 1r minus 6. And then we go, hey, can I factor the back still? And we can. What times what makes negative 6 and subtracts to give me negative 1? So 3 times 2. Give that one the negative. So my final factors, don't forget the 2 out front, are 2 quantity x minus 3, x plus 2. So this bottom one, this last one, part C, is a combination of greatest common factor and factoring using the x. This top one was just greatest common factor, and this one was just factoring with the x. Okay, how'd you do? Okay, for number 3, go ahead and pause the video. Get me the vertex on both of these and see if you can count the stretch. All right, let's look and see how you did. Did you see that this is out 1, 2, 3, 4, 5? And then counting up, you have to be careful because it's not just counting by ones. Look over here. 4, 8, 12, 16. This one's all the way up at 36. How'd you do? Okay, now let's talk about the stretch. Remember that normal parent stretch would be out 1, down 1? Oh, it's not. Out 1, down 1, 2, 3. Well, it's not counting by ones, so it's not down 3. It's down 4, 8, 12. So the stretch is actually 12. So plugging this whole thing into the equation, writing the function, we get f of x equals. There's a negative because it's an upside down parabola. X minus 5 squared, coming from the front part of the vertex, the h, and then plus 36. Oops, sorry guys. Forgot the stretch. There's a negative because it's upside down. It's a 12 from the stretch. X minus 5 squared plus 36. Okay, let's go see the other vertex. This one is back, let's see, 5, 7, 8, 9, 10, 11, 12, 13, and up 2. Did you get negative 13 too? And then the stretch does not go out 1, up 1. It goes out 2, up 1. Normally out 2 is up 4. Out 2, up 4. So this is up 1 of the normal 4. Your stretch is 1/4. So here I go writing the equation. It's a right side up parabola, so it's positive 1/4 x minus a negative 13 squared plus 2. How'd you do writing that equation? All right, we just did this word problem in class together, so we're bumping down to these. Here we go. Tia or Tehani's way. Which one are you doing? So for this first one, 64, this could be done easily with the neon green sheet, doing Tehani's way. What's another way of saying 64? We could rewrite 64 as 4 to the third, and then times that negative 1/3 already existing exponent. 3 times a third is just 1. So like 3 times 1/3 is 3/3 is just 1. Some of you realize you can just cross cancel there. So what we get here, if those 3's cross out, is we get 4 to the negative 1. Final simplified answer, because of the negative exponent, is 1/4. Okay, the next one has a 625. Looking at that neon green sheet, couldn't I rewrite 625 as 5 to the 4th? But this is 1 over 625, so I'm going to call it 5 to the negative 4. This got rewritten as this into an equivalent expression. Now don't forget about this little 3/4 that was already existing. 4 times 3/4, those 4's cross out again, leaving me 5 to the negative 3. That becomes 1 over 5 to the third, or 1 over 125. Okay, this next one, the top is already simplified, and the bottom needs to become 10 to the 1, 2, 3 zeros, third. Now we're going to do the subtract rule. 10 to the 3x plus 5 minus 3. And so that leaves me 10 to the 3x plus, you got it, 2. Last but not least, this kind of turns into a big mama, so make sure you're prepared. This is definitely on the test. It's 4c to the negative 5th happening 2 times. That's just the front part. And then it's this back part, 2c to the 4th. 2c to the 4th. 2c to the 4th. Happening 3 times. So go multiply this out. 4 times 4 makes 16. Do the add rule. Negative 5 and negative 5 is negative 10. 2 times 2 times 2 is 8. C to the 4th, C to the 4th, C to the 4th. 4 plus 4 is 8 plus 4 is 12. And remember, there was a shortcut. I could have done 4 squared, negative 5 times 2 to get this. And I could have done 2 to the third is 8. 4 times 3 is 12. But anyways, shower the power shortcut would have worked. My final step is 16 times 8. And then we do the add rule for the negative 10 exponent and the positive 2. What is negative 10? Sorry, I meant plus 12. It's just going to give me a positive 2. Final simplified answer, 128 c squared. Okay, so this answer was 1/4, 1 125th, 10 to the 3/2 plus 2 in there. All right, those were the Tehani's way, A, B, and C. Now let's look at Tia's way. I'm doing cubed root, so I'm looking for groups of 3. So what times what times what equals 64. You got it. Now, there's a negative in there, guys. There's a negative in there. So since it's cubed root, this is actually a negative 4, negative 4, negative 4. And then x to the 11th. And we're looking for groups of 3. So a negative 4 can come out. An x, another x, another x. And then x squared is going to stay underneath. Don't forget about this little index of 3 that we need to have in our final answer. All right, next one is 5th root of b to the 8th. We're looking for groups of 5. And 5th root of 243. So break that down. 243 is 3 times 81. or 3 times 9 times 9. Well, 9 could just be another 3 times 3 and another 3 times 3. So looking for groups of 5, 1, 2, 3, 4, 5. I got a B that comes out and 3 that stay under, and this whole 3 comes out. So I'm going to get B, 5th root of B cubed, and I'm going to get a 3 on the bottom. The whole 3 comes out. All right, I'm on part G. At the bottom, it needs to be simplified first, so leave the top alone for just a second. And the bottom becomes a to the 14th and b to the negative 14th. Now we can do the subtract rule. 2 just stays there. A to the 4th minus 14 and b to the 3rd minus negative 14 is going to become 2a to the negative 10th, b to the 17th. Final answer, 2b to the 17th on top, a to the 10th on the bottom. Hang on, I'm going to write that to the right instead of below. Two stays on top, a to the 10th moves down, b to the 17th stays up. All right, last but not least, anything that's to the power of 1/3 can be rewritten as cubed root of p to the 7th, q to the 9th. That means that there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going for groups of 3. So a p squared comes out. 1, 2, 3 q's. And then cubed root of p squared is left underneath because there wasn't a group of 3. That guy's done. So if you're feeling bad about this radicals exponent section, I cannot stress to you enough to rewrite the problem, practice it again, check the answer. Rewrite the problem, practice it again, check the answer. Doing problems over and over again and checking the answer is how we repetitively get used to the math. Okay, I'm going to pause the video there for the front of the page. We're going to go to the back on the next video.